I remain your brother, edu-aider. You're welcome back to my platform on my YouTube channel, Mathematics with Edu-aider. I remain my humble self. Thank you for joining me. Now, please make sure and endeavor that as you watch my videos, you are doing me and yourself a favor. Please subscribe. As you're watching, if you see anything that you need to make comments about, if you're wild, if you're inspired, you were inspired, if you actually learned something or it's something you need to call my attention to, please make your comments known. I appreciate that. Make your likes, then when you add the likes, you equally, apart from likes, so just like I said, not only likes, you can share. Yeah, you share. You make the right things you need to do, then I will love that. Now today we've gone under differential calculus. I started that, we mentioned I did something on first principle. Then we made examples, illustrated diagrammatically what first principle is, and how changing x results in changing y, and how we can use that to calculate our differentiation, that is changing y, changing x, and how that is equal to the what? To the what? As the limits of that same change in y, change in x, as the change in x tends to 0. And now we equally said that is equal to what? To the slope of any form of either a curve or a function, yes, or at the turning point. That is what we mentioned in that video, and we went ahead, we spoke of different calculating the differentiation of different functions, special cases of that. Cos x giving us minus sin x giving us cos x, tan x giving us sec square x, then sec x giving us sec x tan x, cosec x giving us what? Minus cosec x, cot x, and cot x giving us what? Minus cosec square x. And we have a lot of them. So we are dealing with product rule now. Product rule. What do we have in product rule? From the word product, it means the multiplication of two or more functions. Simple. So we have this. Let's do this. If you have this, and this, the first one. You have one. I said product rule. This means if you have this, how we go with product rule. We have V. Okay, let me write it. Okay, I'm still writing V. The V, the U, the X. That means V will multiply differentiation of U with respect to X, then plus U will multiply the differentiation of V with respect to X. This can be for any other thing. For example, I can have it as V dp. Okay, I can have this as P dq dt plus q, then we have dp dt. What do I mean by that? It means I can have them in different functions. Yeah, I have v with respect to x, I have u with respect to x, I can have p with respect to t, and I have q2 with respect to t. Do you get? So I can say something like q is equal to 3t squared plus 1, and p is equal to what? Let me say 2t minus 3t squared. So I'm differentiating these two of them with respect to t. So as I've written my p, I have the q, the t. Yeah, differentiate with respect to t plus q. Differential of what? P with respect to t. So there is no particular, you just don't understand the concept. Now we solve our examples. Don't forget, take this to be u, take this to be v. So what do we have now? It should be 2x minus 2 times, any other can come first, is product. product is commutative. So we go. So we have this, but you need to just know that from knowing sake. So you have the u dx. This is u. Differentiate this. We differentiate u. We have what? 3. Then plus, what is our u? 3x plus 1 times, differentiate this, we are going to be having 2. So that becomes 6x minus 6 plus 6x plus 2. So what do we have? We have 6x plus 6x minus 6 plus 2. And that becomes 12x minus 4. So what do we have? We have 4 open bracket 3x minus 1. This is what our dy dx is equal to. So that's 1. Let's see if we can solve question 2 here. Oh no, let me just do the wiping. So we have 2 now to go. Question 2. Cos x tan x. Forget u, this is v. So v will be tan x. Du. If you differentiate cos x from what I gave in the previous video, you are going to be having minus sin x. You see that? Then plus v du, then u cos x, product of tan x. You differentiate tan x, you get what? You get sec square x. Do you see that? So what do we have here now? You can say we have minus sin x tan x plus cos x times sec square x is what? 1 over cos square x, because sec x is 1 over cos x. So this cancel this. So we have our answer to be minus sin x tan x plus 1 upon cos x. So that's what the y the x is equal to. That is that. Then we go again. If you can simplify this, you simplify. If you can't, you stop. But learn to simplify to the simplest form. Break down to the simplest form so that you can always have your answer in the option given. 3. You have 4x exponential of 3x. V exponential of 3x times du, which is differential of this, which is 4, plus, you differentiate this, you have 4. Do you get that? So you have what again? You have this to be written as exponential of 3x. Oh no, differentiate this, you have differentiate the core, which is 3 times 3, then exponential of 3x. That's all we are meant to do. So you have 4 exponential of 3x plus 12 exponential of 3x. And that can be equal to what? 4 plus 12, that is 16 exponential of 3x. That's our dy dx. So that's what we have to do on this video. It is straightforward and simple. Thank you for joining me.